Question 5.6 wants us to determine the point of interaction of the graph f and x-axis of symmetry of G that has a negative gradient. If you look at your answer sheet, there are two ways of doing it, and in both ways they have used words instead of maths or let's say numbers in most of them. So I'm just going to explain to you what they are saying in those words, and we will go through both the solution. Now, our symmetry of G is a linear equation. It has the general equation y is equals to mx plus c. There are two of them. There is one with a positive gradient, and there is one with the negative gradient. Now, one thing we know for certain is either the positive or the negative has to pass through this point here. And this is then the intersection between our horizontal asymptote and our vertical asymptote. So we know it has a point, and that point is D. And we have solved for D. D is 2 and minus 1. So let's go ahead and solve for our equation. For our gradient, we'll substitute the negative gradient. Then we can go ahead and substitute in our point to get our intercept. We will have minus 1 is equals to minus 2 plus c. Okay, go take that to the other side. Our c is equals to 1. So our equation says y is equals to minus x plus c. Now we are looking for a point where this graph is equals to our log base graph. Now, this is not a point where we can equate, because equating will take time from us. But it's something that you can visually kind of see, right? As to, oh, if I have a negative graph in that direction, I should expect it to come over here. And I kind of can see that it might pass minus 1 and 0. So I know now that my x-intercept for my log graph is going to be 1 and 0. And I say, okay, let me check for my axis of symmetry. What is its x-intercept? Right. So our x-intercept is when our y is equals to 0. We'll go ahead and substitute that in. And we'll see that x is equals to 1. Therefore, it has an x-intercept of 1 and 0. And we can clearly see that is where the interaction is happening. Let's go to the second method. For method 2, we acknowledge that for our axis of symmetry that is negative, our gradient will be equals to minus 1. So what does that mean? It means that when my x increases by 1, my y decreases by 1. Or I can say when my x is decreased by 1, my y will increase by 1. So now taking that into consideration, you can kind of draw it, and you would see, okay, my x would decrease by 1. So it's going from a value of 2, and it must go to a value of 1, right? The x value. And what's going to happen to your graph? Your graph is going to increase, or your y value is going to increase by 1, and you'll find yourself at that point. And that point is 1 and 0. And you will also acknowledge that that point also exists on the graph of f. Then you can make a conclusion that says the line of symmetry meets f at the point 1 and 0.